All right, next we want to look at finding any relative extrema for the function f of x equals 1 minus x to the 1/3. This is a really interesting problem because something a little tricky happens here when we take the derivative. So what we want to do first, take that derivative because we want to use that first derivative test, find critical values. Critical values can be a point where the derivative is equal to 0 or where it's a non-differentiable point where the derivative does not exist. We want to take the derivative. So the derivative of this, derivative of 1 is 0, and derivative of this is going to be negative 1/3 x minus 1. So this is 3. 1 minus 3 is negative 2 over 3. So let's rewrite this though. So it's negative 1 over 3x to the 2/3. So that's our derivative. Let's think about that for a second. So my next step is going to be finding critical values. And the critical values, just misspelled critical there. Critical values are going to be where the derivative is equal to 0 or where the derivative does not exist, where we can't take the derivative at points where the derivative is non-differentiable, or points where the graph is non-differentiable. So if I set this derivative equal to 0, negative 1 over 3x to the 2/3 equal to 0, what ends up happening is I can't solve this. I can't set the derivative equal to 0. I can't solve for x. So that means that I don't have any points where the graph is going to be a horizontal tangent, meaning a horizontal is going to flatten out anywhere because I can't solve this. But here's what you want to keep in mind. But that statement about the derivative not existing. So if I were to take some sort of c value, plug in a derivative, and it does not exist. Well, look at that. If I plug in 0 into here, into my derivative, what ends up happening? Negative 1 over 0. We can't do that. Can't have negative 1 over 0. So that means at x equal to 0 is a critical value. I just misspelled I almost did it before. No, I just did it for real. Skip the C. Critical value. There it is. X equals 0 is a critical value because we cannot plug in 0 into the derivative. So since we cannot plug 0 into the derivative, then that means x equals 0 is a critical value. Now again, nothing happened here. When I set the derivative equal to 0, I can't solve this. Like if you want to think of it as like cross multiplication, 0 times x to the 2/3 is 0. You get negative 1 equal to 0. It's a false statement. So that means like, okay, I can't solve the derivative. So that means we don't have any points where it's a horizontal tangent, meaning it flattens out. But we do have a point where the derivative does not exist. So at x equal to 0. Which means that it's going to corner out. It's going to do something like this. It's going to corner out or do something fancy, or not necessarily just cornering out, but it could have a horizontal tangent. Like the graph could do something like this, like that. Like kind of go completely vertical for a split second there. So those are some possibilities of things that could happen in different graphs. But if you just look at this function here, you might get an idea of like, okay, I think I know what's going to happen. It's going to be a vertical tangent based off of this original function here. So since we have that critical value, what we want to know is what's happening to the left of that critical value, so negative infinity to 0. And then we want to know what's happening to the right of that critical value, so 0 to infinity. So we're going to take some points and plug them into the first derivative here, so f prime of negative 1 I'm going to have to use. Unfortunately, 0 is the dividing line. 0 is usually the go-to point if it's in that interval, but fortunately 0 is in both of our intervals here. So I'm going to test out f prime of negative 1. I'm going to plug in negative 1 into this. And negatives and weird exponential, weird exponent, like fraction exponents, gets a little messy. So I would not be too embarrassed to just go to the calculator and just get a double check there. But it's actually not super crazy because if you think about it, if we're plugging in negative 1, this is squaring it. So that's going to be a positive either way. And then 3 times a positive, negative over a positive is going to be negative. So here is going to be a negative. So that means that it's a value less than 0. That means that this interval is going to be decreasing. Same thing happens over here. Positive 1, don't really care what that is. It's going to be positive. 3 times a positive is positive. Negative over a positive is also a negative. So that's also going to be decreasing. All right, so that's interesting. So from, let me get the y value that corresponds with 0. So 0, and then I'm going to take f of 0 into my original function, which is just 1 minus 0 to the 1/3 is 0, so 1 minus 0 is 1. So 0, 1. So it's decreasing coming in, and it's decreasing going out. So here's the big question. I don't know how good you are with graphs, but like, is it doing this? Is it coming out from here? And hopefully you're kind of familiar with that. It might look like the cube root of x. But if you need to check, like, just take a couple x values or just take a couple points and just kind of identify, is it doing this? Is it doing that? Is it coming in a little bit steep? Like, what is it doing? And just take a couple x values. So I'm going to take -6. So I'm going to do f of -6 just to get an idea of what's happening here. So 1 minus -6 to the 1/3. Positive 2.8. So what's going to happen there is it's coming like this a little bit, and then it's going into that critical value that we found, and it's going vertical for like a split second, and then it's going to go back out like that. And if you take a test point over here, like you want to get f of like 6, if you plugged in 6 into the original function, you'd see that it's just, and my graph is a little bit off, but that's what it's going to look like. It's going to be that motion. So it's going completely vertical right there at that critical value. So relative extrema. Do we have a relative extrema? The answer is no. No relative extrema. Because it's not bottoming out, it's not maximizing, nothing's happening. It's just decreasing, boom, it's going vertical, and then boom, decreasing more. So we have no relative extrema in this problem.